Someone just asked me why we need to learn statistics. I will explain you something like this. When we do the research, that means we are going to find out something new, or that no people know before in the past. We just find out what it is or what is the result of that, and then when we try to get the data, most of data is a number. How can we make conclusion about a lot of number? The way to do that is statistics. Just trying to tell you that statistics is the way to make the conclusion, the way to answer your research proposal. When we when we do research, we have the objective or the purposes. Any research have their own purposes or objective, and then how to answer that. The statistics can help to answer that. Uh, that is the importance of statistics. So I would like to mute all of you first. May I mute all of you just for a while? For a while, don't worry. You can hear me, I believe. Yeah, yeah. Okay, 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 okay. Now you can hear me. I am going to tell you that the statistic is good for everyone to make a conclusion to answer your own objective. When people do the research, the most important thing in the research is about the objective of the research, or sometimes some people call purposes, or sometimes people call aim. It depends on the institute, it depends on the university. So anyway, that means the university have purpose to do something, and the way to answer that purpose is about the data, and then we need to make the conclusion, and we use statistics to make the conclusion. Mm. And statistics make the data become like a reliable. If we just see the data, how many peso, how many dollar do you have per month, and everyone have a lot of money. So how can we make the like the mm, the represent of that thing, or of that uh, variable? The way to explain some variable is about statistics. So that is the importance of statistics. I would like to say that. Mm, yeah. And we need to learn statistics because of this. And then today, the topic of today is about the data. Did you? Oh, I have to let you unmute all of you. Yeah.
You are now
Someone read
unmuted.
something from the website or from the link that I have provided for you about the data. Do you know what is the data? No. Ah. So let I ask you again.
Sir?
Did you go
Sir?
to the link, that I provided to you, or somewhere? Yeah, yeah, yeah. That's good.
Yes.
Yeah,
Yes,
that's good.
yes, we
That's good.
did, sir.
Okay.
Yes, we
So
did.
that's good. That means if you don't want to come to join the class, and then you can go to the website and read it, or I post some like a YouTube like that for you, and then you can try to learn from somewhere. That's okay. Yeah, that's fine. And when you come to me, I just would like to encourage you to learn, or I give you some short content for you all of you. Mm. So now I am going to talk about the data. The data. So do you know what is the data now? Is that difficult to you? AQM, you lovely. You show your hand. Okay, please.
Yes.
Mm.
Yes. It's a collection of facts. It's a collection of facts. It's like values and
Yeah, yes.
measurements. And why is Anton laughing?
Yeah.
Okay. And it can be qualitative or
Right.
quantitative.
Right. Thank you so much,
So,
AQM. But the
yeah.
the data that we are going to focusing on is about the number that is only quantitative data. So that so now from now when I say the data, I normally mean the number. I normally mean the number. Actually, it's not only the number. Do not remember that the data is a number. That is not true. The data sometimes is information, explanation, or something. Everything that is the data. But when I'm going to teach about the statistic, I need to say the number is the data because I cannot analyze the data without the number. Mm. So most of the time when I say the data, that is the number. Mm. So when we see that the data is a number, and now I am going to talk about the type of data. Type of data. I mean the data is have two types. The data have two types. Two types. The first one is continuous, and another one, what is it? Uh,
Discrete.
yeah, discrete is,
Discrete.
or uncontinuous,
Discrete.
or discontinuous.
Discrete, sir.
Uh, or yeah, you may say discrete.
Continuous.
I will show you something like the temperature. The temperature is continuous. When we say the uh, how how many Celsius, Michelle, in Mongolia now? No, you do not know. You feel cold, but you do not know how temperature is. Hmm. Uh,
Now we close all the
5
windows.
Celsius.
It's so warm.
5
5.
Celsius. Celsius or centigrade. Centigrade.
Yes, 5. It's cloudy where you
Celsius
live.
or centigrade.
Yes,
Ah,
5
how about
Celsius.
you, Roxanne? How many? 44.
Sir, 44.
Ah, wow. I believe you. 3:30
It's
p.m.
3:30
44.
p.m.
Okay.
Yes.
So this is
Yes.
when the temperature move from 5 to 6 to 7 until 44, the temperature will continue as no cut point. So this is the meaning of continuous data. Uh, and when we say, how many people in this class? How many people in this class? So can you tell me how many people in this class now? Let I count.
9.
2,
Uh,
3, 4,
9
5,
11.
people.
6,
Yeah,
7,
right. Good.
11.
You clever. 11. So,
11? Nasaan yung
uh,
iba?
yeah, you
Wala mang
clever.
webcam.
We have 11 now. So, yeah. So when we talk about the people or the number of people it cannot continuous. We have to count 1, 2, 3. We cannot have 3.5 people. We cannot have that. So that means that means uh, people is decreased, right? Yeah.
It
So this only
decreased.
two types of the data. Why I talk about this? Because when some statistic need to identify what type of data, and we use different statistics. So I talk about the type of data because, for example, if we would like to find the correlation between two things, we need to see the first variable is it decrease,
Yes.
concrete, sorry, mm, and continuous or discontinuous. We need to think about it sometime in the future. We will learn about it. So this is the importance of the type of the data. You need to have ability to identify type of data. If I ask you when I how old how old are you? Suppose when I ask you, you don't need to answer. When I ask you how old are you? Age, what type of age? Is continue or discontinue?
Continuous.
Continuous.
Continuous. Yeah, continuous.
Continuous.
So age is continuous.
It's continuous.
You cannot cut it. Yeah, continuous. So S
Continuously.
is continuous. And how about the book? The book. How many book in your house? Hmm. Yeah, yeah, yeah,
Discrete.
yeah. So now I
Discrete.
think everyone understand what the meaning of this. Huh? Who
Script.
said something? No. Yeah, I think so. Yeah,
Sir,
yeah, I
only a
think so.
delay of reaction
Okay,
maybe.
so now I believe everyone understand what is the type and what kind of the data, something like this. You can you can discriminate between continuous and discontinuous already. So then I'm going to talk about the level of the data. Ah, did anyone read something about the level of the data? Did anyone read something about the
Babalik mo lang.
wait a minute,
I'm
Annabelle,
sorry, sir. What's that?
I,
The
Tawagan kita
yes,
mamaya.
you Annabelle.
May,
So let I
may
ask again.
online class.
I'm
Wait
sorry,
a minute,
sir.
sorry.
What's that
I'm going
about,
to ask
sir?
you again. Did anyone
What's the question, sir?
read the meaning of the level of the data? What is the level of the data? Let I yeah level of the data. Ah,
Level. Level?
how many level of the data?
Levels of data. Levels, data
Who
levels.
said that?
Num
Who
3.
said 3? Michelle, you said 3?
What's that?
Did we watch it?
From
Did
the
we watch it
rain.
from the... Yes, sir. We watch
From
it
the
from the
rain.
link.
Where is the rain?
Send the link.
Oh, from the link. Oh, from the
A
link.
link, sir. From the link. From the
Ah,
one you
I
sent.
think that link need to
The,
be deleted.
yes, yes, yes.
Need to be deleted. No, data have 4 level. Anyone see that? Data have 4 level. Yeah,
Oh, 4.
Ah,
Oh, but
yeah,
sir,
yeah.
I
the
think the
information
link
and
is
You
ratio
have
for
to
are
put
put
a different
together.
the
answer.
first and the fourth together. Yeah, yeah, yeah. That's still okay. That's still okay.
Yes.
So now I would
Interval
just
and
say the data have 4 level. When people ask you how many level of the data, you need to answer 4. You need to answer 4. 4 level. 4 level. Yeah, right.
4.
Roxanne. Yeah,
Okay.
right. 4 level. That is the right answer. The first one,
4.
I would like to talk about the fourth one first. The fourth one. The fourth one first. The fourth one is about ratio. Yeah, it's about ratio. ratio. Yeah,
For
ratio.
what?
Sorry. Yeah, ratio.
Ratio.
Ratio is
Ah,
mean
sorry.
Ratio.
if the
Ratio.
data
Ratio.
within
Yes.
the ratio. The ratio is mean something that we can evaluate with the number. We can find the zero, the real zero. The real zero. When I say, how many money do I have? I say I have 0 baht, or 0 peso or 0 baht or $0. That means I have no money.
Mm-hmm.
And when I say I have 1 baht, 2 baht, 3 baht, something like this,
Ratio.
so I can count 1, 2, 3, 4, 5, 6, 7 like this. This is the ratio, the level of the ratio. Uh, The first one, we can make the conclusion later. The first one is about interval. Interval. Yeah. Interval. Interval is
Interval.
Interval.
interval is like
Interval.
the score. When you take the test. When you take the test, and then you get when you get 10, you get 9, you get 8, you get 0. The score, the point. That is something that you can count. You can compare between 7 and 8 and 9, something like this. You can compare, you can count. But when we talk about the zero, zero mark, that is not real zero. That is not real zero. So when you got zero, that means you cannot answer the right answer. You cannot make the right answer for the test. That doesn't mean you have no idea, you have no knowledge in your head. You have some knowledge in your head, but you cannot make the right answer from the test. Are you confused about this? I am going to say the interval is something that look the same like a ratio, but only thing different is about the zero. The zero is not real zero. For example, when we say the temperature is 0 degrees Celsius. The temperature is 0 degrees Celsius. That doesn't mean have no temperature. There is some temperature. There is some 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 heat or some uh, some temperature, but we just estimate that is 0. We import the 0. That is not real. That is not real. Yeah. You can read more in the future next time. And then the second one, what is the second one? The second, ordinal.
Original.
Yeah, ordinal scale. Ordinal is like a, it's like a length. When
Ordinal.
you see the Miss Universe, Miss Universe, they will eventually pronounce who is the first, who is the second, who is the third, like this. This is ordinal. Is that easy? Not difficult. Ordinal is mean like a number 1, number 2, number 3. Yeah. Is that okay? The distance between number 1 and number 2 may be different. From number 2 to number 3. The distance between each other may be different. For example, this is let I put it. For example, let I do this. Let I show you this. For example, this is number 1. The number 2 may be closer to the number 1, but the number 3 is far away. So the distance between 1 and 2 and 2 and 3 is not the same. 1 and 2 and 2 and 3 not the same. This is ordinal. If you notice the interval and ratio, they have the same distance between the number. For example, 1, 2, 3, 4, something like this. They will have the same distance, but ordinal is different. Ordinal different distance. And the last one is nominal. This is the number 1, but nominal is just a number. For example, the house number, number 1, number 2, number 3. This number is no meaning. Cannot compare between the number 1 and number 2. Cannot compare number 2 and number 3. This is nominal. When we talk about gender, most of the time when we do the research, we will survey something that is gender. What is your gender? And people answer the sample answer you male, and someone say female, someone say male and female. And then when we use statistics to analyze the something like a gender, we need to make the number represent male and female. For example, 0 and 1 or something like this. And this number just nominal. This number is nominal. Cannot minus between 1 and 0, something like this. Cannot do something like this. Cannot compute. Cannot compare. Nominal. Are you confused about this? No, not now. No, not now. That's all right. That's good. So the next thing today I would like to say,
okay.
what I want to talk about is about the distribution of the data. The last thing, when we have collected the data, when we have collected the number, lot of number. For example, if I ask all of you now, how old are you? How old are you? Everyone just tell one number. Everyone just tell me one number. And when I bring all number together, when I bring all number together, and I put it in one area in.
Uh-huh.
So when I collect the number and then I got possible this is the line. May I build the line? May I the line? So okay, I make the line here, and then you can see the line now, right?
Okay.
Good, good. Okay, good. Yeah,
Yes.
huh?
Yes.
Some of you
Yes,
cannot
sir.
see the line.
Not yet.
I think maybe just wait for this.
See, everyone see the line. Yeah. Back line. Okay, that's okay. Back
Yes.
line.
Only the black line, sir?
You can see now.
Okay.
Yeah, 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 yeah,
Yep.
yeah.
Yes.
And this is
Horizontal,
0.
vertical
This
line.
is 0.
This one is probably the most important for your use because we're going to talk about the normal distribution. And if you've had stats or you're currently in a stats class, I'm sure you have heard about the normal distribution. You've probably have heard of the idea of the bell curve. And this is the same idea. The normal distribution is probably the one we use the most in first year stats classes. So it is by far the most important thing to understand as you get into higher level statistics or more advanced topics even in that first year, because so much is based on understanding the concept of the normal distribution. So let's go ahead and talk about it. Now, a quick review about continuous probability distributions. So in my previous video, we talked about uniform continuous probability distributions. Now we know that the total area of the distribution has to add up to 1. And then for this continuous uniform distribution, any point beyond the edges is 0. So all of our area, all of our probability is in this rectangular shape. Now a continuous probability distribution, a uniform one like this, we give one end A on the left, we call the other end B there on the right, and then we talk about the width of this rectangle. Well, the width of the rectangle is B minus A. Of course, the distance to B from the axis minus the distance from the axis to A leaves us with the distance between A and B. So that is the width of this rectangle. Now we know the area is 1. So just using some very simple math, we know that the area of a rectangle is its height times its width. In this case, it equals 1. So we know 2 of those things, so we can solve for the third, which is the height. So we use some simple algebra to come up with the height of our distribution here. So it's 1 divided by B minus A. So that is the height of this rectangle. The area is 1, the width is B minus A, therefore the height is 1 divided by B minus A. Now, with this continuous uniform distribution, we talked about a very important concept. The probability of any specific outcome in a continuous distribution is 0. And we'll review why that is here in a second. All we can do in a continuous distribution is find the probability over an interval of outcomes or a range of outcomes. So think about this. Let's say, well, we know this entire rectangle, the probability has to equal 1. Now that's divided in half, right down the middle. So we know that 1/2 is going to have a probability of 0.5, the other half will have a probability of 0.5. Well, that's 1 over 2. That's very simple. Now what about if we divide it into 4 equal bars, right down, up and down, vertically? Well, that's 1 over 4. So each bar would be 0.25, the next one 0.25, 0.25, and 0.25. Now let's say we divide it into 10 bars. Well, that's 1 divided by 10. So each bar would be 0.1. Let's say we divide it into 100 bars. Well, each bar has a probability of 0.01. Divide it into 1,000 bars. Divide it into 1,000,000 bars. You see what's going to happen here? As we divide it up, into more and more vertical bars, they get more narrow and more narrow and more narrow. The probability goes down, 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 down. And as that happens, as we divide it up into an infinite number of bars, the probability of any one of them approaches 0. So in real life, the way to think about this in terms of continuous data is maybe you had a chemistry class and you go over to the scale and you weigh a chemical on the scale in the chemistry lab. Well, that scale may have 3 or 4 or maybe even 5 digits, past the decimal point. Well, it's the same concept here. In continuous data, the probability of any specific outcome is 0 because the decimals could keep going on forever. So that's the difference between a coin flip or a die roll, which has 2 and 6 outcomes respectively, or continuous data, which has an infinite number of outcomes, and it's only limited by the precision of whatever measuring instrument you are using. Okay? So the idea of any given outcome, the probability is 0, therefore we can only find the probability over a range of outcomes is fundamental to understanding the normal distribution. And that's why I spent 4 minutes explaining it. In case you didn't watch the video on that this slide is in on continuous uniform distributions. So, you've seen this shape before. I bet you have. Maybe something like this. And in the front or back of your book, your stats book, you've probably seen something like this with a whole bunch of crazy numbers all over it. It has the bell curve there, and it has percentages and deviations and z-scores and t-scores and stanines and all kinds of crazy stuff. But oftentimes, you don't really understand where this stuff comes from. So the idea of this video is to we're not going to explain everything in this graphic right here, but we're going to explain several things in it so you can solve problems using the normal distribution. But I'm sure you've seen this before. So what about the normal distribution? So oftentimes data is described as being normal in the statistical sense, but what does that mean? So let's talk about the frequency by which some events occur, both natural and man-made. So some natural things, human, the height of an adult human, the temperature outside, a person's blood pressure, etc. So those are events that occur in nature that tend to follow a normal distribution. Or man-made, machined products, maybe in quality control situations, financial data, sales data, and things like that in business. For these measures, the average of the mean tends to be very frequent, while measures away from the mean are less and less frequent. So the data in these situations tends to clump around the mean. So let's take a look at the normal distribution and learn more about its properties. So here it is. Now, from at least my view, from an aesthetic sense, in terms of something being sort of attractive, I guess you would say, I think the normal curve is a very aesthetic shape. But there are some things about the shape we should know. On the ends, we call these the tails. So we have the lower tail and the upper tail. Sometimes you'll just see here the tails. Underneath the curve is the probability area. So everything under the curve is what we're interested in. We're not interested in anything outside of this curved shape, just the area underneath it. Another characteristic of the normal curve is that it is symmetric. So it has symmetry down the middle. So the left half is the exact same as the right half when we're talking about the perfect theoretical normal distribution. Now the high point, or the top of the normal curve, is the mean, the median, and the mode. So the top of the curve there is the same. So the mean, the median, and the mode are the same thing. So right there. Now the mean down at the bottom just tells you where the position is of your normal curve. As far as the shape goes, that's largely affected or largely influenced by the standard deviation. And we'll talk about each one of those here in a minute. So the two parameters that really give the normal distribution its position and shape are the mean, mu, and the standard deviation, sigma. So let's talk about the mean. So I've used just the standard normal curve here, so I've set the mean to 0. Of course, there's no axis at the bottom to tell you that. But we'll just say the mean of this curve is 0. Now, I could slide it over to the left. So a mean could be negative 12.3. That's fine. So the mean just kind of slides it over to the left. Or we could have a mean of 10, and that would slide it over to the right. So the mean here can be any numerical value. And what it does is it slides the entire distribution side to side, left to right. And this is very, very important later on when you are trying to determine if two samples or two populations have statistically different means. So maybe you are doing an experiment and you have one group or one, something that gets the experimental treatment and you're expecting something to increase. Then you maybe have a control group where you're expecting no increase. So you would be interested if the means in these two groups are statistically different or have significant differences, statistically speaking. Well, that's what we're talking about here. Now, it would also have to do with the variance, but if the curves are very far apart, the means are far apart, then you might have some indication that whatever experimental treatment you did affect that group. Okay? So the mean just slides the distribution side to side. Now, standard deviation, in many ways, is more interesting, at least I think. So what it does is it gives the curve really its overall shape. So this is sort of our normal curve. Now this shape, as you can see, it is taller in the middle and narrower on the sides. If our standard deviation is smaller, it makes that curve more narrow and taller. So you can see sort of the grayish blue curve is below the orange one at the bottom, and it's above it at the top. And just keep in mind that whatever area difference is at the low side, it's the same as the difference there at the top, or that it goes above. So just a smaller standard deviation will make the curve, assuming the same mean, narrower and taller. Now the opposite is also true. If the standard deviation is larger, it will flatten and widen our distribution because our deviations on average are further away from the mean. So the standard deviation gives us the shape in terms of how sort of short and wide or narrow and tall the distribution is, and of course the mean slides it from side to side.